Hello students, today we will proceed to look at the exercise 8.2 in the chapter Differentials and Partial Derivatives. So for exercise 8.2, we will look at some concepts here. The definition that function f be from a comma b interval to the set of real numbers be a differentiable function. For x, element of a comma b and delta x, the increment given to x. We define the differential of x by df equal to f prime of x into delta x. What this basically means is that we are trying to approximate the change in the function with respect to x. So this basically means that suppose f of x is the function given by the green curve, then as you move by a small dx value on the x-axis, how much change happens on the y-axis is f of x plus dx. But an approximated value is given by this triangle, that is by the red tangent line. So in that, the opposite side, which is given by dy equal to f prime x dx, that is the change. So this is where the differential comes into play. So the properties of differentiation, they also apply for the differential. So here you look at the properties that for real valued functions of a real variable. If f is a constant function, then df is 0. If f of x equal to x, df equal to 1 of dx. If f is differentiable and it's multiplied by a constant c, then d of cf equal to cf prime x dx. If f and g are differentiable, then d of f plus g is equal to df plus dg, which in turn is f prime of x dx plus g prime of x dx. So then next is the product rule of differentiation. That is, if f of g are differentiable, then d of fg is equal to f into dg plus g into df. That is given expanded as f of x into g prime x plus f prime x gx dx. Similarly, we look at the differentiation, the division rule of differentiation. That is, d of f by g is equal to g of df minus f of dg divided by g square. This in turn we can expand as shown here. Now for composite functions, that is, if f and g are differentiable and h is equal to f for g, then dh is equal to f prime of g x into g prime of x dx. So this is like the chain rule of differentiation. Eighth and ninth, they deal with exponential and logarithmic functions, which is a special case. So following this, we look at the questions. So in exercise 8.2, we'll be dealing mostly with 4 questions. It is question 1, part 3, question 4, and then question 8 and question 11. So question 1 is find the differential for the following function. Subsection 3 is y equal to e to the power of x square minus 5x plus 7 into cosine of x square minus 1. So this involves a couple of properties which we studied before. So here we have the solution for the problem. What we do is we write this product y as u. U is equal to e power x square minus 5x plus 7, which is equal to e to the power of t. So we define some variables as small u and small t. And then v is cosine of x square minus 1, which is given as cosine of m. So here, if we look at u prime, we have to use the product rule. So u prime is equal to d by dt of e power t into d by dx of t. So this is the composite function property which we are using. So when we differentiate e power t, we again get e power t, which is basically the same function, e power x square minus 5x plus 7. And then we have the differentiating at 2x, this function x square minus 5x plus 7. So we get 2x minus 5. So here we look at then we look at small v. So small v is given by cosine of x square minus 1 equal to cosine of m. So here applying the chain rule, we get differentiation of cos m is minus sine m, which is minus sine of x square minus 1. And d by dx of m is 2x, as given here. So we have dy by dx is equal to u prime v plus v prime u. So here we have dy by dx equal to u prime v. So the first is substitute this first value here, this first term, then multiply by v cosine of x square minus 1. And for v prime, we write down minus sine x square minus 1 into 2x and this first term u. Now when we simplify, we take out e to the power of x square minus 5x plus 7. And here we have 2x cosine x square minus 1, then minus 2x sine x square minus 1 minus 5 cosine of x square minus 1. So the final solution is given by this differential. So basically we take the dx term to the right side. So we have dy equal to e to the power of x square minus 5x plus 7 into 2x minus 5 cosine x square minus 1 minus 2x sine x square minus 1 dx. So now we move on to the next question here. So we move on to the next question, which is question 4. Assuming log e to the base 10 is equal to 0.4343, find an approximate value of logarithm of 1003 to the base 10. So for this, we will use the concept of differentials. First, there's a property of logarithms which we recall from lower standards, that log of b to the base a is equal to product of log of c to the base a and log of b to the base c. So using this, we can write log of x to the base 10 as log of e to the base 10 into log of x to the base e. We write this way because in differentiation, we know that d by dx of log x is 1 by x. And this is true for the natural logarithm. Natural logarithm as in the base is e. So let f of x equal to log x to the base 10, and we choose x naught as 1000. And then we choose the dx or delta x as 3. So f of 1000, we know straightforward. 1000 to the base 10 is 3 because 10 cube is 1000. To find f of 1003, what we do is the linear approximation of differentials. That is, f of x naught plus delta x is approximately equal to f of x naught plus f prime x naught into dx. Here f prime of x, when we do the differentiation, we get 0.434 comes outside, and d by dx of log x is 1 by x. So to find f prime of 1000, we write that as f prime of 1000 is 0.4343 divided by 1000. Therefore, f of 1003 is written as f of x naught, which is 3, and f prime x naught, which is this value, into dx, which is 3. So what we get is 3 plus 0.001303. So the final solution is 3.001303. Now we move on to the next question. In a newly developed city, it is estimated that the voting population in thousands will increase according to V of t is equal to 30 plus 12t square minus t cube, where t is between 0 to 8, time in years. Find the approximate change in voters for time change from 4 to 4, 1 by 6th of a year. So we have this function V of t given as 30 plus 12t square minus t cube. Now, by writing the linear approximation of the function V of t is equal to V of t naught plus V prime of t naught into t minus t naught. Here we have to find an approximate change in voters as V by 4, because V by 4 is easy for us to evaluate. So we write down the change in voters as delta V. We have to calculate for delta V. So delta V as a function of time is approximately equal to dV, which is equal to V prime of t into dt, which is V prime of t into delta t. Now t minus t naught is equal to delta t equal to 4 1 by 6 minus 4, which is 1 by 6. So dV by dt is, if we differentiate 30, we get 0. When we differentiate 12t square, we get 24t. And when we differentiate t cube, we get 3t square. So finally, we have V prime of 4 is 24 into 4 minus 3 into 4 square, which gives us 48. So delta V, approximate change in voters, is equal to V prime of 4 into del T. V prime of 4 is 48, and this is 1 by 6, so we have 4. And the unit is thousands, so the change is 4,000 voters. Now we look at the next problem here. So the next question we will be looking at is question number 11, which is a coat of paint of thickness 0.2 centimeters is applied to the faces of a cube whose edge is 10 centimeter. Use the differentials to find approximately how many cubic centimeters of paint is used to paint this cube. Also calculate the exact amount of paint used to paint this cube. So with this problem, we can see how the approximation matches with the exact amount. So this is a approximate diagram which I have drawn here. So the inner cube is a cube, and next we have the outer cube here. So the outer cube has delta x extra on all the sides of the cube. Now we write the volume of cube as V of x equal to x cube. So this problem actually, there is a small confusion over here. So 0.2 centimeters is the 0.2 centimeters is the paint thickness on both sides of the face. So we have volume of cube V of x equal to x cube. So x naught is 10 and paint thickness dx is 0.2 centimeter. So with differentials, we write the change in volume as delta V is approximately equal to dV. So dV of x is equal to V prime x into dx. So V prime of x is 3x square and dx we have as 0.2. So in this problem, we have the delta x value to be only along, say, 1 point. On either side of the faces, we have a coat paint thickness. But here we will only consider that the total thickness is 0.2 along one edge. So we have b prime of x 3x square 3 into 10 square into 0.2. So we get 3 into 10 into 2, which is 60 centimeter cube. So this is the approximate change in volume. Cc of paint used is 60. Now to find the exact amount of paint used, we apply the formula completely. That is volume of cube with edge 10.2 minus volume of a cube with edge 10. So it is 10.2 cube minus 10 cube. This you can do using a calculator. Here I have used the identity like a minus b into a square plus ab plus b square. So using this, I'm getting the value 61.208. So we see that there is a small difference like of 1.2 centimeter cube between the two solutions. So with this, we finish this exercise. If you have any doubts, please mention in the comments. உங்களுக்கு எக்ஸ்பிளனேஷன் தமிழ்ல வேணா சொல்லுங்க, அதுக்கேற்ற மாதிரி நான் தமிழ்ல மாற்றி எக்ஸ்பிளனேஷன்ஸ் தரேன். தேங்க்யூ.